Questions on turning points and intercepts are very poorly answered. Always have been. I don't know why. They come at the end of the syllabus maybe. Maybe they're not taught very well. Here is a curve. It's a quadratic curve. There are 4 interesting things about this curve. Not very interesting. The y-intercept, we know that's y to the sky, and x is across. And the x-intercepts, and this point down here, which is the turning point. Why is it a turning point? Well, the gradient here is negative. The gradient on this side is positive. And at this point here, the gradient is absolutely 0. It goes straight across here. The tangent would go like that. And that is the turning point. There's a turning point on a curve that goes like that. And in that case, it's at the top. Again, when the gradient is 0. Let's look at these things. This is the curve and these are the numbers. So we can look at these mathematically a little now. The y-intercept, probably the least interesting thing about this graph. Y equals x squared minus 2x minus 3. When x is 0, you are on the y-axis, and this is where the y-intercept is. So when we make x equal to 0, we get y is equal to minus 3. The x squared and the 2x both go to 0. So 0 minus 3 is the turning point. Sorry, it's the intercept. So 0 minus 3 is the y-intercept. There's always a 0 here because it's always x equals 0 on the y-axis. Turning point. Now this is little known thing. I don't know why, but there's a line of symmetry going through a quadratic curve. And for that reason, this line goes right through the middle of here, between minus 1 and 3. Minus 1 and 3, difference is 4. So 1, 2, 1, 2. Yep, it's right in the middle, and it goes down here. Now, if I hadn't covered this with blue, you would see that that was 1. So at the turning point, x equals 1. So we've got x equals 1. We also know that this equation is true for every point on the curve, therefore it's true for the turning point. So I can put 1 into here, and that will give me 1. 2x minus 2x is minus 2, minus 3. That equals minus 4. So as you might have guessed, this point here is 1 minus 4. That's the turning point. That's worth a couple of marks. The really interesting thing, I think, is the next bit. When we're looking at the x-intercepts, these points here, where the curve goes through the x-axis. Consider for a moment this equation. If you're asked to solve that, well, if you have a question like this, you will be asked to solve that, and you will notice that this is the same as the equation. That is crucial. Same as the equation of the line. So we know for every point on the red line, y is equal to x squared minus 2x minus 3. But here, this is equal to 0. So that is equal to 0. So y is equal to 0. Where is y equal to 0 on this curve? Y. It's here and here. The two x-intercepts. So that's set minus 1, 0 and 3, 0. Notice that y is 0 in both cases. Shall we just check if this is correct? Let's imagine that x equals 3. X squared minus 2x minus 3 gives us 3 squared is 9, minus 2x is minus 6, minus 3. That's equal to 0. So 3 is a solution of this equation. And 3 comes from here. What you're betting? Minus 1 is a solution as well. X equals minus 1. That's the equation. X squared is 1. So minus 1 squared is positive 1. Minus 2x. Minus 2 times minus 1. Double negative gives us plus 2. Minus 3 is 3. That gives us 0. Am I saying that the solution to this can be found simply by reading 3 and minus 1 off this chart? Yes, I am. That's 2 marks as well. So let's have a look at an example question. The diagram shows the graph of x squared plus 2x minus 3. What is the y coordinate when x equals 0? Okay, well, That's going to be 0, that's going to be 0, so I reckon it's going to be just minus 3, which is the answer. What is the coordinates of the y-intercept? Well, we can read that off here. There's the y-intercept. And so x is equal to 0, obviously, coming down here to minus 3. It is 0 minus 3. Minus 3 twice. This is two ways, really, of asking the same question. What is the coordinates of the turning point of the curve? Well, I can read it off, can't I? I can see that it's minus 1 and minus 4. Or I can say there's a line of symmetry. The middle of it is minus 1, so x is minus 1. And I'm going to put x is minus 1 into this equation. I get minus 1 squared is 1 again. Minus 1 times 2 is minus 2. And there's a minus 3. So that gives me minus 4. Minus 4. So minus 1 minus 4 is the turning point of the curve. And now I'm using the diagram to solve x squared plus 2x minus 3 equals 0. Which coincidentally is the same equation as the line. And we have discovered that if that is true and it equals 0, then when y equals 0, x is equal to minus 3 and 1. And I've just read those off here. Absolutely brilliant. Now, if I wanted to, I would check. I probably wouldn't with a question like this. But there we go. Minus 3, x squared is 9. Plus 2x is minus 6. Minus 3 is 0. And the other one, 1. 1 squared is 1. Plus 2 times 1 is 2. Minus 3, 0. I feel very good about that. As I say, I'm more likely to get the check wrong than just reading off minus 3 and 1. So I wouldn't bother to check that. Here's a harder question. Not enough graph stuff, as far as I'm concerned. The diagram shows the graph of y equals x squared minus 4x minus 5. What is the coordinates of the y-intercept? What is the coordinates of the turning point of the curve? And use the diagram to solve this. And again, this is the same as that. So, what is the coordinates of the y-intercept? Well, it's 5, isn't it? It's not. You can't see that it's 5. But if you put 0 into this, you get that y is equal to x squared is going to be 0, 4x is going to be 0, minus 5. So 0 minus 5 is the intercept. What is the coordinates of the turning point of the curve? Well, that's down here. And again, there is a line of symmetry, and it goes from 1 to 5. So we're looking for the middle, which is 3. 1, 2, 3. Yeah, 2 is the point. So x is equal to 2. And now I put this into our equation. So y is x squared, which is 4, minus 4x, which is minus 8, and the minus 5. And that gives me minus 9. And I guess that's what it is, isn't it? It's in between minus 8 and minus 10. But in this case, we couldn't read it. We had to use the equation. So it's 2 minus 9. Use the diagram to solve x squared minus 4x minus 5 equals 0. Brilliant. That's the same as the graph. So I'm just going to read minus 1 and 5. Equals 0. When y equals 0, x is equal to minus 1 and 5. Am I going to check? Probably not in the real world, but we're not in the real world, are we? So there we are. There's a check. I'd be very happy about that. I might check later on in the exam. So here is one for you. Go back with the video if you can't remember it. I've given you a lot of information to think about quite quickly. Let's see how you get on. Hope you did well. Here's the solution. We needed a bit more space. The diagram shows x squared plus 2x minus 8 equals y. So there's the curve. Write down the y-intercept of the curve. Well, we can see actually it goes through minus 8. X is going to be 0 because we're on the y-axis. And if I put in 0 to this, x squared, that's 0, 2x, that's 0 because x is 0. So y is equal to minus 8. I think it's pretty clear that the answer is 0 minus 8. Remember, always going to have a x value as 0 because you're on the y-axis. Find the coordinates of the turning point of the curve. I can see that one coming. Right, let's think. There is the line of symmetry because it's midway between minus 4 and 2. That's a distance of 6. 1, 2, 3, yes, it's always going to be down there. That's where it is. X is equal to -1 at that point, so I put -1 into this equation to find this point here, and I get y is equal to x squared. Well, -1 squared is 1. Plus 2x, well, that's going to give me -2x, and then -8. So that all adds up to -9. And you can see again, yeah, it's below -8, isn't it? I mean, a common mistake when this was in an exam was to put this as -8. People probably had no idea and just a bit random. Anyway, the answer is -1, -9. And incredible, use the diagram to solve this equation. And amazingly, this equation is the same as the line. Brilliant. This is only 1 mark. It's a bit cheeky, really. -4 and 2. When y equals that, and that equals 0, when y is equal to 0, and x is equal to -4 and 2. Oh, it took longer to say it than it did to write it down and get it right. 1 mark is miserable. Uncheck it. No, I don't think I'd bother, but either. So there we are. That works out. So, a quick recap of what is going on. Turning points. Bit of symmetry. There's the turning point. Put your line down the middle. You know what the value is. X is equal to -1. Then take your x equal to -1 and put it into the equation, and you will find y is equal to -9. That's turning points. Second thing, if blah, 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 you're asked to solve this equation, and this will always be the same as this. That's the whole point of the question. So you know if x squared plus 2x minus 8 equals 0, then y equals 0 because y is equal to that. And where does y equal 0? Here. Oh no, and here. So -4 and 2, and that's the answer. Now, this is a very hard subject. First of all, you've got to remember what turning points are. If you don't know, you can't answer the question, and then solving that equation can take you forever. I hope we've taken something hard and made it, still a bit tricky, but best of luck. Why not subscribe if you've enjoyed this video, or even if you haven't. There's plenty more coming. See you soon.